Hello, I'm Michael Wybrow, and in this video I'm going to give you an overview of MVC, or Model View Controller Architecture, and how it relates to iOS. So, Model View Controller is a design pattern. The idea behind it is that it splits core tasks in an application, especially to promote code reusability. So what it does is it splits um, the parts of the program into a model, which is the data and state of the program, the view, which is how that model is presented to the user, and then a controller that sits between and provides the business logic and allows the view to update the model and the model to update the view. So there isn't a hard rule regarding how this is implemented, and you'll see it implemented in different places. iOS is no exception to this rule. So as an example, sometimes the model and the controller get implemented together, and sometimes they're completely separated. So this should sound a little familiar to you. Even in Lab 1, you would have seen some separation of this kind. You used a storyboard to create the interface. So that's obviously the view component. You stored some data in a person class, and you can think of that as the model, though that information could just as easily have been stored in the view controller class. And obviously the view controller is the controller. We used actions and outlets to connect the view to the view controller and allow it to use information from the model. So this is something you've done already, and look, Lab 1 was sort of a forward look at many of the topics we'll be covering both this week and in future weeks, because we wanted to start you off with a complete app. That week covered a lot of things that we didn't go into great detail about, but we'll fill in the gaps on later. So back to MVC. This is the basic idea. We have a view, we have the model, and the controller sits between. And typically the user is interacting with the view. So that's this arrow that talks about user action to the controller. The controller understands and hears that user action, and it updates the model. When the model updates, it notifies the controller and it makes changes to the view. And typically it's the user adjusting the view, and the model, if it's say data that's synced from the internet, could be being changed from the internet or from some other data source as well. So that's worth taking into account. All right, so let's have a look at each of these components in turn. For the model, as we said, it relates specifically to the data that is accessed and stored by the application. The person class was a very simple example of this in our week 1 lab. And the model can take many forms. It could just be a simple class that stores some program state. It could be a database or a class rather that interacts with a database, or it could involve a syncing engine, or it could be any combination of the above. So Model View Controller Architecture basically says that the model should only interact with the controller. It should be completely agnostic and not understand the view. So view should never update the model directly. They should only notify the controller of any interactions which can update a model. So the model code is only concerned about the data. That's the rule. On to the view. So the view obviously is what the user sees. It's a visual representation of a model, and typically it's a user interface that's presented to a user. It handles the way that data is presented, and it also handles the manner in which they can interact with it. How are these implemented in iOS? Well, they're implemented as storyboards or nib files, and you've seen a simple example of this already. And they can also be implemented via code declarations, as in you can create user interfaces via code. We'll see some examples of that later in the unit. It's also important to stress here that a view can have no direct relationship with the model that it represents. A simple example of this is a table view, something we'll cover in detail next week. And a table view is a generic representation of a list. It has cells, rows in the table view that represent data items, and they have a label, they might have an icon, they might have a button that represents some action that can be performed on them. And that class could be used for a shopping list app or an address book or anything else, and it doesn't need to be specific in any way. And the important thing here is the table view does not directly interact with the shopping list or the address book. It just says the user tapped on row 4, and it's up to the controller to say, oh, row 4 represents this item. I'm going to change something in my data model. So the controller is obviously doing most of the heavy lifting, and it acts as a mediator between the model and the view. And it's responsible for making changes in both directions. Controllers in iOS are represented via view controller classes, and we create these to interact with the interface screens that we define in our storyboard. So our lab exercise last week had one controller because there was only one screen. Our lab exercise this week will have two controllers, one controller for the initial entry screen and a second controller for a second screen. Let's just go through a simple example of MVC. This is a contacts app. So imagine you just have an application that has a list of contacts and address book. The view here would be a piece of UI, a table view. The controller would be a subclass of a predefined iOS class called UI Table View Controller. This is a view controller that understands it's working with a particular type of view and implements a lot of that functionality, and then you can override it in order to specify your specific version of that class. So it updates the table, it allows the user to modify it, and it connects the storyboard with the contact classes, so a list of contacts, say. And the model is the object representing the contact data, or it could be a collection of these, like I said, like an array or a list of them. And you can imagine this could be stored in a persistent database via something like a technology like Core Data, which is something we'll cover in week 4. Okay, that was an overview of Model View Controller. Thanks for watching.